Alright, and here we are with the 4-1 assignment. And our directions here are to convert from DMS, which means degrees, minutes, and seconds, to decimal form. Super. So, to get from degrees to its decimal form, pretty much we will have 23 as the whole digit, but then we need to make 12 out of 60 into our fraction. So 12/60ths is going to be 1/5, which is 0.2. So that means that we have 23.2 degrees instead of minutes and seconds and all that good stuff. Alright. Our next one is number 2. We've got 35 and 24. So 24 minutes. So again, it's going to be 35 point, and then it's 24 over 60. So 24 over 60 can be reduced. Whoops. Gotta get my calculator on here. And so it could be 2/5, but of course we want a decimal, so 2/5 is 0.4. So 35.4 degrees. Alright, the next one has seconds, so that's lovely. But the idea is that we still have 118. To that we're going to add whatever 44/60ths is, and then to that now we have the next one of seconds, so we're going to add whatever 15/3600ths is. So 44/60ths is 0.73 repeating, and 15/3600 is 0.00416 repeating. Alright, and so if we add those two together, we're going to get 118.7375 actually. How nice is that? Again, if you keep all of the decimal, it will do that. Alright, and then the same thing happens in the next one, but now we have 48 and 30/60ths and 36/3600ths. So that means we're going to take 48 plus 0.5 plus 36, whoops, that's raising to a power of, and then 0.01. Okay. So 48.51 degrees. Basically changing everything from a base of 36 or 3,600 to a base of 10. So yay, because we like base 10, it helps us solve everything. Alright. The next one we want to convert from decimal form to degrees. Okay, so now we're going to go back. So that means that I need to take 0.2 and multiply it by 60, and that's going to get me my minutes in whatever the whole number is going to give me. And apparently that's 12, and so since there's no other decimal, there's going to be 0 seconds. So that means it's 21 degrees, 12 seconds, and technically 0/10 of a second. I'm sorry, 12 minutes. Alright, next one is going to be taking the 49 and adding to it the 0.7 times 60. So 0.7 is just 42. So again, there's going to be no seconds. So it's 49 degrees, 42 seconds, minutes, and 0 seconds. Apparently I'm getting my words all mixed up. Okay, so the next one is going to be 118.32 times 60 added to that. And so this one is going to get you 19.2. So then you need to take that 0.2 and multiply by another 60, because now you've multiplied it by 3,600. And so 0.2 times 60, whoops, that's not it, is 12. So we have 118, 19, and 12, which means our answer is 118 degrees, 19 minutes, and 12 seconds. Alright, next one. We still have 99, but to that we're going to add our decimal of 0.37 times 60. And so 0.37 is 22.2, but then we take that 0.2 and multiply it by 60 and get the 12 that we had the last time. So 12 and 22 and 99 are our... Hi, honey. Okay, thank you. Oh my gosh. Okay, so 22 minutes and 12 seconds. There it is. Alright. Now we're going to convert from degrees, minutes, and seconds into radians. Alright, degrees into radians. So in order to do this, we take our degrees and multiply by pi over 180, and that's going to equal our radians. So I'm going to multiply this by pi over 180, which really just kind of tells me that I have 60 over 180 and then a pi tacked onto it. And 60 over 180 is a third. And we don't usually have the pi afterwards if we can put it in the numerator, so pi over 3 is our radian equivalent to 60 degrees. Alright, the next one is 90 degrees, so 90 times pi over 180 is going to leave us with technically 90 over 180 and then a little pi afterwards. 90 over 180 is a half, and so of course we put that pi in the numerator and get pi over 2. Alright, now they want you to convert from radians to degrees. So from radians to degrees, you take your radians and multiply that value by 180 over pi, so it'll cancel out the pi that was in the top, and then you get your degrees. So pi over 10 is going to be multiplied by 180 over pi. Again, the pi's cancel, and so we have 180 over 10, or 18 degrees. And then 3 pi over 5 is going to be multiplied by 180 over pi, our conversion. Again, the pi's cancel, and so we're left with 3 times 180, which is 540 over 5. And 540 divided by 5 is 100 degrees. Alright, the next one here, we're going to use the appropriate arc length formula. So let's see. Both of them are in radians, and so your appropriate arc length formula is S equals r theta. You don't need the pi over 180 because it's already in radians, as you can see. Thinking back to the formulas, if it was in degrees, your equation would be r theta pi over 180, so that it could convert the degrees into radians and then use it. Very fun. Alright, so number 26, we're taking the s, which we don't know, and multiplying your r and theta. And so our r is 1, and our theta is 70, and so we're doing 1 times 70 to be our s, so 70. And this is arc length, and so we would do centimeters. Alright, and then number 27, again, s is r theta, and so s is actually 1.5, r we don't know, and theta is pi over 4. And so to solve, that multiplier is going to be divided. And so, let's see, what am I trying to do? Oh, feet, so I do want that. So, we get our decimal of 1.91, and we are doing feet for our radius. I thought maybe I'd keep it in terms of pi, but we are talking about a radius, so we don't really need pi. Radians, yes, but radius, no, which of course is not a helpful combo. Alright, so then we have a 16 compass bearing shown here. And we want north corresponding to angle of 0 degrees, okay? And the other angles are measured clockwise, so clockwise means the way that a hand would move on a clock from the north. So, for instance, this is 90 degrees, and this is 180 degrees for a circle, and then 270, and then potentially 360 would be back up at top. So, we need to find the angle in degrees that describes the compass bearing. Alright, northeast. Oh, well, it's right here. Oh, wait, yeah, northeast is this one. So we need to find the measure of the angle right here. So basically we need to figure out if this is 90 degrees here, how many times do we divide 90? Well, there's a space here, 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 and here. So 90 divided 4 ways is 22.5. That's gross. So that means that this is 22.5 degrees. The next one is going to be 45 degrees. And then 67.5 degrees. So if we want northeast, that's going to be 45 degrees. Then they want north-northeast, and so north-northeast means that we're actually going to this one here. So we've already marked that as 22.5. And then they want west-southwest. Okay, so that's down here, which means that we'll go all the way to, well, actually, let's think of it this way, 270, but take away one of those spaces, so take away a 22.5. So 270 degrees, but then a little bit less of 22.5, meaning you have 247.5 degrees. Oh, and then they want you to find the rest of these. Okay, so south-southwest. Let's see, where's that? Oh, this one. So south-southwest means that we're going to take 180 and add one of the tick marks. So 180 plus 22.5. Means that we're at 202.5. West-northwest. Let's see. Get a new color. West-northwest. Boop. Is right there. So that's going to be 270 plus 22.5. So 292.5. And then the last one is north-northwest. That's this one. So almost 360, but less one tick mark. So 360 minus 22.5, which is 337.5. Alright. Then we get a fun word problem here. So 2 Coast Guard Patrol boats leave Cape May at the same time. One travels with a bearing of 42 degrees 30 minutes, and the other with a bearing of 52 degrees 12 minutes. If they travel at the same speed, approximately how far apart will they be when they are 25 statute miles from Cape May? So basically we're going to try to find this distance between the two boats. Yes, in an arc, but of course, if you think about it at the beginning, it's not really in an arc. So we are talking about that arc distance. So on that note, let's see. This first boat has 42 degrees 30 minutes. So if we divide that by 60, we're actually going to get 42.5 degrees. The other one is 52 and 12 minutes. So 12 divided by 60 leaves with 52.2. Alright. And so we're actually going to do 2 arc lengths and then subtract them. Or we could do 1 arc length and subtract the angles to begin with. So the angle of this actual arc that we're trying to find the distance of is going to be 52.2 minus 42.5. And so that missing arc length is going to be 9.7 degrees. And so we're really just going to use our arc length of r theta, but we are in degrees, so times pi over 180. So the r, they said, is 25 miles, so they've traveled 25 miles. The degree is what we just found, 9.7, and then times pi over 180 as well. That's going to get us our arc length in miles of that arc. So 25 times 9.7 times pi over 180, and we get 4.2324. Decided to get really into the decimals there. Okay. So along that curve, they are 4.2324 miles away. Alright, and then our last problem here is talking about mechanical engineering. A simple pulley with the given radius r is used to lift heavy objects and its position 10 feet above the ground. So I see that in the diagram. Given that the pulley rotates 0 degrees, oh, sorry, I decided that was a 0, theta degrees, so whatever they give you, determine the height to which the object has been lifted. So really what we're looking for then is how much of this rope, which would be potentially, well, I drew that badly, which would be going around this circle, so it's arc lengths, how much of that rope has moved, because therefore that is how much the object has gone up. So in the first one here in part A, we need to use our arc length. They give you a degree, so we're going to need to do r theta pi over 180. In fact, for both of these. And so then our r is 4, our theta is 720. And so to find our distance here, we're going to multiply each of those. That's going to give us 50.27. And this is inches, and of course it was given to you in feet, so if you want to transfer that back, that's fine, but 50.27 inches is how far the box has been lifted. And then for part B, it's the same idea, only now we have 2 feet times our theta times pi over 180. Guess I should have put that as an r first. And so 2 is put in for our radius, 180 is put in for our theta, and then pi over 180. So multiplying that out, we get 6.28 feet, and that was in feet because they gave you a radius of 2 feet. So whatever distance the radius is in, that is the distance that's going to be used for the arc length once you find it. Sweet. Alright, so that is our assignment from 4.1. Yeah, 4.1 assignment. Woohoo!